All right, so continuing and dealing with circles, now we're going to work on tangents and circumscribed angles. So circumscribed is going to be on the outside of a circle, now not the inscribed of it. So first we'll start with our essential question: what are the key theorems about tangents to a circle? So the biggest one is this first one here, the tangent radius theorem. And what that states is that when a line is tangent to a circle, and tangent means it just touches at one point, so in this case it'd be that single point there, then it's perpendicular to the radius drawn to that point of tangency. And so that's huge because that gives us a 90-degree angle in there. And that helps out a lot with being able to deal with problems in circles. So let's immediately put this to practice here. So number one, if yx is a tangent segment, okay, so that's our line right here, we know that's tangent, and OX is our radius, what is the measure of angle XYO? Okay, so we know that since these are tangent, that's now a 90-degree angle. Draw that a little better there. Well, now we have a triangle there. All three angles in the triangle add up to 180. So I have 58 plus 90, so that's 148. And then I just go 180 minus that 148. And that gives me 32. So then that angle is 32 degrees. And then just showing that in a different little form. As we know, call this one X, I'll call it Y down here to go with the letter that's already there. And so we know that 90 plus 58 plus Y equals 180. So then solving from there, you see we get the 148 when we combine our like terms. We get Y equals 180. We subtract that 148 and we still get 32 degrees there. All right, so go ahead and do that number 2 there. So pause the video as you work through this one. So then your answers here, we're looking for angle WVO and angle VWO. So WVO is that one there. There's off our tangent, so we know that one is 90 degrees. So that's a nice simple one to deal with. And then VWO is, now we're down here. So that one's going to be 18 degrees to check your work. All right, so then we have this concept of an angle formed outside of a circle by an intersection. So now we're talking about that angle 1 right there. And we have really 3 cases. So we have 2 tangents, like we see drawn here. We have 2 secants. Now a secant means it intersects the circle twice. So once, twice, once, twice. So that's 2 secants. And then we have a tangent and a secant. Okay, so all of those 3 cases. The nice thing about them is regardless of those cases, if our angle is formed outside the circle, it is essentially this formula here. 1/2 the major arc minus the minor arc. And as we look at this, major is going to be your biggest, so our major arc would be this portion here, and then your minor arc is going to be your smaller one there, and you'd subtract those, multiply by 1/2, and there's your angle. So let's do some problems here. So we have a little bit of work we have to do here to think through this one. They're not all just going to give you the value. So our major arc is 243, so that we know that the measure of angle C is going to be equal to 1/2 the major arc, which is 243, and then minus the minor arc. Well, we got to figure that out. Well, we do know that a complete circle is 360, so 360 minus our 243, which we already know, and that gives us a 117. So So then our minor arc is 117. So subtracting those out, we know the measure of angle C is going to be 1/2 of 126, which is 63 degrees. Okay, so that was a tangent. Okay, over here on number 2, we have a tangent and a secant this time, but it doesn't matter. We're still looking for a measure of angle T here, and it is 1/2 our major arc, which is our 211, minus our minor arc, which is now just that portion, because this portion over here is not included in those. That's one of the differences in a secant versus a tangent. So we're subtracting 73, and we get 1/2 of 138, and then multiply that by the 1/2, and we get measure of angle T equals 69 degrees. All right, so let's look at number 3 now. Work over here. So now we have multiple things going on. So we know our angle out here is 30 degrees, and that's going to be equal to 1/2 the major arc, which in this case our major arc is 105. And we're going to subtract our minor arc, which is 15x. And in this case, we have 2 secants, because we intersect twice there and intersect twice there. So this arc and that arc are not being included. So simplifying through, just because I know I'm going to have some fractions there, I'm going to actually multiply by 2 on each side. That cancels out that 1/2, and we get 60 degrees equals 105 minus 15x. And we can kind of drop that. And so I'm going to go ahead and subtract the 105 here. And we get negative 45 equals negative 15x. Divide by negative 15. And x equals 3. And so substituting that in, if it was asked, it doesn't specifically say, but if we're substituting that in, that would then give us a 45 there. All right, number 4 here. So we have a tangent and a secant, but again, nothing changes. We have our outside angle, which is 4x plus 12, is equal to 1/2 the major arc, which is the 16x plus 9, minus our minor arc, which is 81. So combine some like terms there, and I get 16x minus 72. So this time I know I'm going to get some nice numbers, so I'll distribute there, and I get 4x plus 12 equals 8x, and then minus 36. So solving, I'm going to add this 36 over, and we get 48, and then subtract 4x. I get 4x there, divide by 4, and x equals 12. If we're to substitute that back in, you get 16 times 12 plus 9 is 201. And then 16 times 4, 64 plus 12 is 76 degrees. All right. So you have 2 problems there, 5 and 6. That is your turn. So go and work on those. So on number 5, your answer for measure of angle T should be 40 degrees. And then on number 6, you should get x equals 8, which then would give you 54. All right, now as we look at 7 and 8, we also know that tangents, when they're tangent, that they have to be that same distance. So very simply put, if I have these two tangent lines here, and this one's 15 and this one's x, well, then I know that x has to equal 15. And then over here, again, we're told they are tangent, so then I know those two segments have to be equal to each other. And then solving from there, subtract x, and we get 2x, subtract 32, and we get negative 56, divided by 2, and we get negative 28 equals x, which in the context of this problem wouldn't work, but we solved for x there properly. And bonus question, can anyone tell me why this does not work in the context of our problem? First person to come to me with it will get a little bonus. So our key theorems about tangents to a circle. So we know that the tangent and the radius form a 90-degree angle, and that two tangent lines are equal length, and then we have the outside angle is equal to 1/2 the major arc minus the minor arc.